Alright, so this is a video that's being made by special request here. A student asked me to do a solution of a problem like this because it's appeared in a couple places. It's appeared in this classwork. It appeared in the actual Mars task that you guys did, and apparently it's appeared on like some star stuff or something like that as well. So I'm going to do this problem with you and kind of give you a good explanation of it. Hopefully it makes sense, and it is based on some information from previous stuff. So first let's get some values in here that we're going to use. Okay, well actually going back. Find the height of liquid in glass 2 when it is half full. Okay, so remember, we're going to find H. Okay? Now glass number 2 is this guy here. We're going to find it when it's half full. Now, the very, very, very important thing that you have to realize, first of all, besides the fact that this problem is not an easy problem, in that it's not as simple as saying this is halfway full because here's 3, half of 3 is 6. Now, we're saying when I've poured in exactly half the amount of liquid that I can pour in. So with this cup right here, I can pour in exactly half the height and I'll have exactly half the volume. This cup, however, is different because the bottom is smaller than the top. This halfway point shows the halfway in height, so as you draw this right here, you can separate these. In fact, I'm going to do that exact thing to help myself with this problem. But this isn't half the volume of this entire glass, and I hope that makes sense, because when I pour this in, this did not fill up halfway. In fact, it's less than halfway, and that's actually a very key part of this problem as I do it. Okay, the other key parts are obviously trying to figure out, we figured out the volume of glass 2 in class, or at least you hopefully did when you did the work, and I have the volume listed here as either 45 pi, or that's cubic centimeters, by the way, or when you multiply by pi, you get 141.37 cubic centimeters. I'm going to go ahead and use this value because it's an exact value, and later I'm going to, gosh, what am I going to say? Later I'm going to round off if I need to. Okay, I multiply by pi, and I'm going to use that stuff, or you might see later that the pi's might cancel out. So that might help you as well. Now glass 3, we had to find the volume of this as well. Oh, I'm sorry. I'm not talking about glass 3. I'm talking about glass 2. The second part of glass 2 was, this was the entire volume, but there was the volume of the spherical portion. I'm going to put hemisphere, half the sphere. So the volume of the hemisphere part, that is this bottom part right here. Okay. The volume of that alone was found by taking half of the volume of what would have been the full sphere, 4/3 pi r cubed, and your r actually was 3. So radius was 3 and cube that. Okay, 3 cubed is 27. 27 divided by 3 is 9. 9 times 4 is 36. 1/2 of 36 is 18. So this will be 18 pi. Okay, so these will be the two important ingredients so far in figuring out this volume, and I'll explain why as I jump over here. So let's see, V glass 2 and V hemisphere. Okay, I'm going to move on over onto the other side. So volume of glass 2 was 45 pi cubic centimeters, and volume hemisphere, sorry that I have to transfer this over, was 18 pi cubic centimeters. Okay, so the question is, okay, well, why do we need these things? Well, here's why. We're going to find the height of liquid in glass 2 when it is half full. That means we need to find out how tall the liquid goes when I've gotten exactly half the volume inside this liquid glass. Now, this liquid glass can hold 45 pi cubic centimeters. Okay? In order to find out what half of that is, you take half of this number right here, 45 pi. So I'm going to find half the volume of glass number 2, which is 1/2 of 45 pi. It's a 5, by the way. 1/2 of 45 pi is 45 divided by 2, 22.5 pi cubic centimeters. So I want to find out the height of this glass when I have a volume of 22.5 cubic centimeters. Okay. Now, in something like a prism, okay, let me backtrack for a second, still explain why this problem is still a little difficult. If I had a prism and the volume of the prism was 45 pi, assuming they use pi for prisms, and then they say, okay, find the height of the prism when it's half full and such, I would take half of it and get 22.5 pi, and then I'd say, well, okay, if volume of a prism is area of base times height, and area of base is like length times width, okay, and then you have some numbers, let's say they give you length and width as like 5 and 6, then you have 22.5 pi equals 5 times 6 times h, and you just solve for h, okay, because you have all these numbers here. The problem is, this glass is not consistent of one formula. It's two different things. It's a cylinder and it's half a sphere. So I can't just use one formula and figure out what all this is. Well, I mean, I can, but it's not just based on one thing. I have to base it on a couple things. I have to add some things together. The volume of glass 2 in total is consisting of the volume of the hemisphere plus the volume of that cylinder that was on top. So again, going back, the volume of the total thing is the volume of the red, which is the hemisphere, plus the volume of the green, which is the cylinder. Now, in order to do this question appropriately, you have to answer this question first. If I'm going to pour half the volume, if I'm going to pour in liquid that's equal to half the volume of this glass, will that be more than this line? Will it be higher than this line? And hopefully, you know your answer is yes. The reason is because the bottom portion has less volume than the top portion. You can do the math to figure it out. We already did a little part of it. There's 18 pi. If you remember, the hemisphere is 18 pi. The whole thing is 45 pi. Well, 18 pi over 45 pi is 18 over 45, which reduces to what? 6 over 15? 6 over 15 is less than 1/2, right? So the bottom is less than half the entire thing. So when you fill this cup more than halfway full, you know that you are definitely at least going to get the bottom portion. Okay? And I hope that makes sense. Again, I'm going to say it one more time. When you fill up this glass halfway full, half the volume, you will have definitely at least covered the bottom, this hemisphere. Okay? Again, I hope that makes sense. When you pour it in, you'll cover up at least the bottom for sure. So if you're for sure going to if you're for sure going to get the bottom, then the volume of glass number 2. Let's take half the. Let's do this. Let's do the volume of the full glass, which is 45 pi, is equal to the volume of the bottom, which remember was 18 pi, plus the volume of the cylinder. Now the volume of the cylinder portion obviously must be 27 pi, but I want to find out what the volume of the cylinder is when I'm looking at half the volume of the glass. So half of this was 22.5 pi, right? We already did that. We already figured out that volume of half this glass would be 22.5 pi. So 22.5 pi, again, would be equal to 18 pi. Remember, we will fill up the bottom portion. We are definitely going to get 18 pi amount out of this. Okay? Plus the volume of the cylinder. Now, the volume of the cylinder in this case must be how much if this is halfway full? Subtract 18 pi from both sides. And you get that the volume of the cylinder is 4.5 pi cubic centimeters. Okay, now we're not done with the problem, but I'm going to box this. Sorry about that. What that means, again, going back, so keep this number in mind, volume cylinder 4.5 pi. What that means is We're pouring this halfway in. And we've got the red right here as part of our liquid that we've poured in. Okay, we've poured in that much. We still need to pour in a little bit more. How much more? 4.5 centimeters more. So we're still going to pour in a little bit more, maybe up to there or something like that, right? And we pour that in. Now we're halfway full with the glass. Question's going to be, okay, this is 3 centimeters tall right here. How tall is this portion right here? Okay, this is part of our unknown. The whole thing is h. This little part I'm going to call x right here. I need to find out what this little x is right here. Okay? How do you figure it out? This is kind of the easier part. We know the volume of this cylinder portion is 4.5 pi cubic centimeters. And the volume of a cylinder, in general, is the area of the base times the height. Okay? Area of a base of a cylinder is the area of a circle, which is pi r squared. This height right now I'm calling x because we're going to solve for x. Okay? So the volume of my cylinder that I'm looking at, that's 4.5 pi, which I'm going to write next time, is pi r squared times x. X will be our unknown. The rest of the values we have. Pi I'm going to keep as pi for now. Okay, volume of our cylinder is 4.5 pi. Okay, that's how much liquid we have filled up in the cylindrical portion. So 4.5 pi equals pi times, we're looking at a radius of 3 right here. Okay, pi r squared, pi times 3 squared times x. Okay, 3 squared is 9. So we have 4.5 pi equals 9 pi times x. Again, x is the one we got to solve for. So divide both sides by 9 pi. 9 pi. If you've ever done division, including pi's, you keep the pi's unless it's pi over pi. Pi over pi is 1, so I'm going to cancel out the pi's. 4.5 over 9. You may use your calculator. I'd let you. But 4.5 is half of 9. So 4.5 over 9 is 1 over 2. And 1 over 2 is an exact value, so I'm going to leave it as 0.5. So x is 0.5. Remember, this was a length, so it's 0.5 centimeters. Okay? We're almost done, and this is actually where I stopped the first time. If you look at the answer key, you'll see where I had 0.5 and I boxed it. But we're not done. X is 0.5 centimeters. That means this portion right here was 0.5 centimeters tall. This part was 3 centimeters tall. So the entire height of the liquid, when I'm halfway up this thing, is 3 plus 0.5. Which, obviously, anyone here knows, 3 plus 0.5 equals 3.5 centimeters. So your final answer, as I go back up, is 3.5 centimeters. Now, if all of this was too much, I'm going to try and revisit it. I don't know if I'll reword anything differently, but hearing it a second time with this in mind might help you out there. There's the final answer. See if I can go through it one more time with the writing in and see if it makes sense. First of all, it says find the height, so we're trying to find h. So h was 3.5, by the way. Find the height of liquid in glass 2 when it is half full. The first thing you have to keep in mind, and the most important part, is you have to make sure that half full does not mean the height, half the height. Okay? In this glass and in this cone glass, it's not going to be half the height because the height doesn't go up the same rate the entire time like the cylinder. In this cylinder, halfway up is exactly half the volume because the cylinder doesn't change at all. This is a prism. This is part prism. It's part a cylinder, but the other part's a sphere. It's half a sphere. So this part grows tremendously in volume as we keep going outward more and more and more. So this gets more liquid in these other portions as we go along. And same with this one. It gets more liquid as we go along, so this liquid rate starts to slow up when you increase height. So halfway up will not be, I mean this is halfway up, but half the volume will not be halfway up for this cone glass and this kind of bowl looking glass, the one that you normally see. This one looks more like a lampshade, I don't know. This looks like most wine glasses I see, I suppose. And this one. Okay, so keeping that in mind, you know that the halfway point is not right here. In fact, you know that it's above it. And that's going to be the next most important part. But before I get to that, let's just make sure that we get the fact that if the volume of the entire thing is 45 pi, okay, if the volume of the entire thing is 45 pi, we're going to find the height of the liquid when it is half full. So when we get half of 45 pi. So we have this volume, take half of it, you get 22.5 pi. This is the volume of the liquid when it's halfway full. So again, that's what that means. Okay? So we're going to use this number in a second. This number represents how much liquid we have poured into this entire thing. We have to find out how tall it is based on that. So here's the next important part. Because we know it crosses this line, because we know it's more than half of this, then we know that when we pour in 22.5 pi cubic centimeters, it will get past this red amount. So we know for sure that we are at least going to get this red amount of liquid in it. Okay, this is a fixed number. This will not change. Whether we pour 18 pi, which is exactly how much this liquid is, whether we pour 18 pi cubic centimeters of liquid or more, we will always at least definitely have this 18 pi, and this will not change. This height of 3 will always be 3. If we poured less, now it's going to be a variable, in which case that's going to be a very difficult problem to solve, and that's only solvable through calculus. It's not even solvable through geometry as far as I'm concerned. So I would ignore that. So we're definitely going to have 3. We'll have 3, a height of 3 plus some extra amount. I call it x. We don't know what this is yet. We have to find out how much it is. To find out what this height is, we have to figure out how much liquid remains when we pour this in. So again, keep in mind, this total amount, as I circle blue, is 22.5 cubic centimeters. This red part is 18 pi cubic centimeters. The remaining part is how much is left, and the rest of it is looked at like a cylindrical shape. It's looked at like a cylinder, like this right here. Okay? This cylinder is what's left, this blue part, blue outline. So let's figure out what that is. To figure out what that is, you go back and you say, all right, if the whole thing's 22.5 pi cubic centimeters of liquid, let's take out 18 pi. Where is it? Okay, starting right here at this threshold. The 22.5 comes from 18 pi from the hemisphere part, because that's definitely going to be there when you pour it in, plus this unknown. We don't know how much this is. So let's figure it out. Subtract 18 pi from both sides, and the remaining amount of volume is 4.5 pi cubic centimeters. So this amount right here in the green is 4.5 pi centimeters. This part's 18 pi centimeters. This adds up. Both these add up to 22.5 pi. Okay? So we have to figure out how tall a cylinder is when it has a radius of 3 and a volume of 4.5, right? This green, this volume, this cylinder right here has an entire volume of 4.5. This is one where you don't know the height. Now, the volume of a cylinder is found through the formula, again, area of base times height. Now, your base is a circle. So when we do area of base, we're doing pi r squared. Remember, it depends on what prism you have. In this case, we had a circle. So the area of your base is pi r squared, and I just called this x because because we're using h later, and I just said let's call this one x. So the volume of our cylinder is defined by pi r squared times x. Our r is 3; it's half of 6, right? Our x is the one we're trying to figure out, and our volume of that cylinder in this particular cylinder is 4.5 pi. Okay, so if the volume is 4.5 pi. What is the height of it when we have a radius of 3? Well, we take 3 and square it, we get 9. So we have 9 pi times x equals 4.5 pi. We divided both sides by 9 pi. Pi's cancel out. Again, the rest is algebra. The rest is division, figuring that out. You get x is 0.5. So this x, remember, this x was this little height right here. It said, how tall was this little portion right there? Now, that wasn't the answer to the question, but this helps answer it for sure. It says, how tall is that little part right there? Because we don't know. We know this part's 3, and we need to do 3 plus x to figure out the height of the entire thing, of this h. So this x we found out was 0.5, half a centimeter tall. So the entire thing is 3 plus 1/2, 3 plus 0.5, which is 3.5, 3.5 centimeters. So when this thing is filled up halfway full, the height of the liquid is at 3.5 centimeters. I hope you can understand why it's not 3. And I'm just going to say that part one more time, and then we'll be done. It's not 3 centimeters because when we fill this up halfway, we're not talking about filling up half the height like this. If we filled up half this height right here, we have a lot more space right here than we have in here. Same with here. When we fill up this half the height, it's not a lot more space, but we have more space up at the top of the glass than we have down here because this curves off. If this looked like a cylinder, like this guy over here, okay, halfway up will give you that because like prisms, the top and bottom are the exact same and they go up straight. But when we unfold this guy, surface area, etc., we're not making a rectangle, we're making something else that's curved differently. So we know that the volume of the bottom half, like literally the bottom half, if we divide this into 3 by its height, the bottom half, the volume, is smaller. So because it's smaller, we know that the halfway point is above it. That's why we know for sure we're going to fill in the red. That's why I said we will for sure have 18 pi cubic centimeters filled up, and the rest we don't know yet. The rest was 4.5 pi in volume. That's how we figured out the height. So this was a long explanation, but I hope the explanation makes sense now. You know, maybe it won't help you. Maybe it'll help you fill out that pool example that we did in the Mars task. But that pool one's still significantly harder because we had to figure out how those lengths varied. But it still was a matter of this part being so important, saying the volume consists of 2 things you got to add together. I guess it started way up here. Consists of 2 things added together. It's not just one thing, and one of them is going to have a variable while you have a fixed rate in the other. Okay. So again, this was asked upon request, and for you at least, I hope it made sense. I hope it was worth your while, other than just the answer key. And I'm not positive that my answer key is exactly written down the exact same way, but you know, you can look at this and maybe it makes sense to you. All right, so I'm going to sign off with that. And if you have any other questions, I sure hope I can help, but otherwise, that was a pretty thorough explanation.